I did for this project. We with Alex first we decided to make the housing. After checking for various concepts, we went with buying housing already made from malls, and then we decided on the placement of the components. The relay and BMS will be mounted on a wooden plank. All these components were searched for in Practiker, um, and we will mount the CSE and fans on walls and the battery terminal close to base and current sensor. Alex made this wiring diagram, and I made the wire size calculation. For this I went for the National Electric Code installation manual, and with the one provided with Allen Electric we could find one with current values for a conductor made of copper. Uh, these are sizes in AVG or kcmil. The only one we needed to be really big was from the battery to the fuse or relay. There the current will be 400 amperes, so we needed a maximum 400 amperes. So we needed a really big conductor. After that, the maximum amperage was not so big at all, so we went with smaller conductors. This is for the selection of the fan. First in the design, we came out with the idea of having a fan that should be around 100 or 200 millimeters maximum in diameter. So with this, we started searching in catalogs provided by ABM or Sunrise for fans. In this we found that normally the values in CFM, that's cubic feet per meter, are should be between 30 or 177, because everything above that was in a price range kind of high, or the input was in AC, and that would create more problems. So we decided to stay with this one. This is the formula we found for calculating how much CFM should we need. The temperature rise I decided on was on 10 degrees Celsius or 50 Fahrenheit for this particular formula. And here we can see how many watts can we pull, how many watts dissipated can we pull with this a fan. So we needed to check if we could find a fan that would work on this range. For calculating the watts dissipated, I checked for a document that said that the best way to calculate the maximum dissipated was 15 the Cold Franklin amps. So because we didn't have the current values provided by the hardware team by this time, I went to calculate for a fan that could cool a 12-volt battery. This because it shouldn't be so much different, especially if we are actually checking for how to cool a 12-volt battery in extreme conditions. This is in the case that the battery is at 0 Fahrenheit, so it should be actually it's like extreme condition. We are only going to cool it in the lab, so our fan should do okay if it works for a 12-volt battery at 0 Fahrenheit. And that we should use for soldering a 12 volt battery. We should use 7.2 volts times the amperage. The maximum amperage is 600, so we went with the maximum amperage, and we found that we could pull with the watt dissipated would be about 4,320 watts. So this didn't work in our range. Our range is below 3,000. So for us to just to be completely sure, we decided on 2 fans instead of only one, and so we divided 4,320 watts between two, and went with 2 fans that could cool this. For the locks, our selection criteria was only dependent on the wire diameter or the mounting components that should be between that should fit in here. We only needed 5 pieces, as explained here, a positive terminal to relay, relay to positive, negative terminal, and negative terminal to positive. So here is an example of how we selected the one with our cable, the one going to our relay. We will have this data, and this is from the Driltec catalog, and we selected this in particular for with our wire to the relay, because it fits the M and the D4 size. This is for selecting the fuse. So we will have this data. We needed this is the fuse that was given to us, and we needed to check if it would fit our specifications. For example, the continuous current rating, it's around 250 amps, and the continuous current rating we needed to be around 200, so 250 feet. The maximum current we could have for this fuse, this is the fuse from the battery to the relay. The maximum current we would have there is around 400 amps, so it can withstand around 5,000 maximum at 48 volt. We have a 48 volt battery, and it's maximum of 58. And the nominal melting, it was good for well, according to hardware and software, should be around this a minimum, but the difference was not so big, so it could have a good responding time. And this is the final design of our housing with the wires. So you can see how everything should look according to our perspective. So that's it, and thank you very much.